So my name is Shibu Jose. I'm the director of the Center for Agroforestry at the University of Missouri. On behalf of the center, it is my pleasure to present to you the 6th annual Agroforestry Symposium, Climatesmart Agriculture, the role of agroforestry. Well, my role here is to introduce Dr. Mark Linnett, but before I do so, let me say a few words. First of all, why did we choose this topic or this theme for the symposium? Well, I am sure that you all will agree with me that it is a timely topic, a very relevant topic. We've been experiencing extreme weather events, and we were talking earlier this morning with the keynote speaker and Tom Sauer, and we all agreed that there is no normal year anymore when you think about agricultural operations. So weather has been, climate has been changing or erratic. What is the role of agroforestry? If you look around, there have been research projects all around the world looking at what agroforestry can do. That's one line of approach. We also have a lot of molecular work going on, breeding work going on, trying to make crops resistant, resilient to extreme weather events, and also animals. But we also have land use approaches like agroforestry that people are trying, and research is still ongoing here at the University of Missouri and elsewhere in the US and around the world. So we wanted to bring in a cross-section of the researchers dealing with this topic here in the US, particularly closer to Missouri, to share their stories, their research with you all today. So throughout the day, an excellent slate of speakers and panelists, and the panelists are primarily landowners, will explore the ever-increasing role of perennials and land use practices like agroforestry in making agriculture climate smart. These speakers are some of the best in their fields, and we are fortunate to bring them to you today. We are also fortunate, as I said earlier, to open the symposium to the public free of charge, and also live stream it so that anyone interested in learning about these topics can tune in. So free live streaming to the global audience. We also have our graduate students and postdocs presenting posters throughout the day. But we have a dedicated poster session at 3:30, so I would encourage all of you to attend the poster session after the symposium is over. And I also encourage all of you, because we have folks from here in Columbia and also from other states attending the symposium here in this room. So use this opportunity for networking. So without further ado, I would like to introduce Dr. Mark Linnett, Senior Associate Dean of the College of Agriculture, Food, and Natural Resources at the University of Missouri, to welcome you all to the symposium and introduce our keynote speaker, Dr. Tom Sauer. Mark?
Thank you, Shibu. It's really nice to be up here to start off this 6th annual symposium for the Center of Agroforestry. This is a center that is near and dear to my heart. I started working as a researcher in agroforestry back in the mid-'80s, but back then this was a black walnut multi-cropping project. And in the early 90s, that project morphed into what we now know as agroforestry. It expanded its scope somewhat. but it feels like coming home to be in front of this audience and to be talking about agroforestry. This is a great center. It's been very successful over the years, and the trajectory suggests that it will continue to be successful. And there's a reason that centers like this find success on this campus. And I just want to mention a couple of things, particularly for those of you who are not from the Columbia campus and aren't familiar with our institution. There are a number of reasons that we have successful centers on this campus, but I'd like to address two of them that I think are pertinent to not only this center, but a couple of other centers on campus that are successful. And that is that we are a diverse campus in terms of the number and kinds of programs that we have in one location. We are in a group of 5 universities across the country that have a diversity of programs that include things like a College of Agriculture, Food and Natural Resources, School of Medicine, Veterinary Medicine, Health Professions, College of Engineering, Business, Education, Arts and Science, and the #1 ranked journalism school in the world. So what that means is we have a diversity of expertise on this campus. So when you create a center like agroforestry, there's a tremendous wealth of expertise to draw on, to bring into this center, and a diversity of backgrounds to bring to problem solving. The other ethic that is very strong on this campus is collaboration. And collaboration is something of a catchphrase right now. Everyone's talking about collaboration. But we live collaboration. And I know that because I hear that from people who visit this campus. And I hear it from people who come to this campus to apply for positions. One of the reasons they want to be here is because we are known to have a collaborative environment in terms of research. And we have administration from campus level down to the college level that endorse collaboration, and we have faculty that embrace it. And it's in that kind of a cultural background that this Center for Agroforestry has been so successful. So, climate-smart agriculture, what a great term, and what an appropriate term for a morning like this. I didn't know how smart I felt about the climate walking over here today. But I think our keynote speaker probably felt pretty much at home. Tom Sauer grew up in Minnesota. He probably thinks this is a late March, early April morning. Just put on your light jacket and walk to work. Tom has training as a soil scientist. He has a bachelor's degree in soil science from University of Wisconsin at Stevens Point, a master's and doctoral degree in soil science from University of Wisconsin at Madison. In 1993, he joined the USDA Agricultural Research Service, ARS, as a research associate in the National Soil Tilth Laboratory. How many of you know what soil tilth means? Ah, good. It's not a term you hear much anymore. As a matter of fact, I think the name has been changed. But that's good. I didn't expect that good a response. Excuse me. 2 years later, he accepted a position as a soil scientist at the Poultry Production and Product Safety Research Unit in Fayetteville, Arkansas. This was still with ARS, where he studied the hydrologic impacts on nutrient transport from poultry litter application on pasture soils. In 1999, Dr. Sauer returned to the Soil Tilth Lab to continue work on animal manure management that included water and air quality projects. His research focus turned to soil management effects on organic matter and greenhouse gas production. These efforts have addressed the potential for land use change, and in particular windbreaks as a climate change adaptation and mitigation practice. His work also addressed the potential environmental impacts of bioenergy production from trees. So very pertinent topics to Symposium on Agroforestry. Dr. Sauer currently serves as the research leader for the Soil, Water, and Air Resource Research Unit at the National Laboratory for Agriculture and Environment. and also serves as the Assistant Director for the USDA's Midwest Climate Hub. This is one of 7 newly established regional climate hubs established by the U.S. Department of Agriculture to address issues of agriculture as it relates to climate change, climate variability. This morning, Dr. Sauer will talk to us about agroforestry for climate-smart agriculture. So would you please join me in welcoming Dr. Tom Sauer, this morning's speaker.
Thank you for the warm welcome to Columbia. It's a great pleasure to be here. Agroforestry has been a personal interest of mine for many years, and so it's a wonderful opportunity to come here and talk to you about climate change and some of the work we've been doing in a broad perspective, and then narrowing it down to some of my personal research, and hopefully setting up some of the perspectives that we might have for later speakers. And I love the program here. It looks very interesting. I'm very much looking forward to it. So I'm going to start with a picture of a statue, and this is part of my story today. I was impressed by the people who knew what tilth meant. When we changed the name of our laboratory, I had spent a decade teaching people what the word tilth meant, and then they changed the name of our lab. So that was a decade wasted, apparently. Who knows who Vasily Vasilyevich Dokuchayev was? Yeah, we have a few people. If you've had an introductory soils course, in one of the first pages, they will list this man as the father of soil science. In July of 2012, I was jet-lagged and had a 6-hour car drive. We stopped in a place called Kamenaya Steppe. I rolled out of the vehicle, turned to my colleague, Dr. Yuri Chendev, and said, "Oh, who's that statue? Who is that?" And he said, "Dokuchayev." I'm like, wow, this country has a statue to a soil scientist. As a man who has 3 soils degrees, not knowing of any other statues to soil scientists in the world, I thought, this is pretty cool. Now, what's even more interesting is that as I learned more about Kamenaya Steppe and its role in Russian agriculture and of Dokuchayev, there's this real strong agroforestry connection. And so that's part of my story today, is the story of Dokuchayev. Right, so climate change. Used to be called global warming, right? That's good that we don't use that term very much anymore, because I wouldn't want to talk about global warming today, because that'd be kind of a hard sell to people, right? But, you know, it's a controversial issue. There's all sorts of perspectives that people have. I like to simplify things, and the way I simplify climate change is, look, climate is changing. It's always been changing. 15,000 years ago, there was a half a mile of ice in Ames, Iowa. Thank goodness the climate changed. It'd be pretty inhospitable right now if it hadn't. So really the questions are, and we need to be more specific. The real issue is, climate has always been changing. Is it change accelerating? Is that bad or good? Is it a threat to us or not? Is it human-induced? Can we do anything about it? Those are the real questions about climate change. So there's a lot out there in the media and the public. You know, this will be one of the topics of our Climate Hub. The public is confused. Lots of people are confused. I'm confused. There's a lot of information. It's not very consistent. And then you have something like this op-ed in the New York Times recently, where the author said, considering all the interactions, large-scale increases in forest cover can actually make global warming worse. Well, there were some pretty strong reactions to this op-ed piece, and I won't go into the details, nor into the actual article that this scientist from Yale was talking about, but let me just say, in my opinion, she wasn't considering all the interactions, unfortunately, and that's sort of the point of that op-ed piece. So we talk a lot about averages, and we were talking about averages just before I came up this morning. they're not very meaningful. You know, there's that old story about the statistician who drowned in the lake of average depth 6 inches. Sometimes averages just aren't very meaningful. Extremes, that's what's important. And so we try to talk a lot more about climate variability. We've had 3 250-year floods in Ames in the last 25 years. In 2012, we probably had the worst drought of my lifetime. That's a lot of variability. And the cost associated with these events is staggering. So this is a map of billion-dollar weather disasters from 1980 to 2012. There's been a lot of them. And I can tell you one of the large players in the global climate change debate is the insurance industry. Because you know those people, they're working the odds, they're working the probabilities all the time. They're paying out for these climate disasters. They're very interested in what the future is going to bring in terms of climate. So, what's our purpose in agriculture? We grow food, right? It's a little bit more complicated. It's food, feed, fuel, and fiber now. We're expecting a lot from our land. Right now we have projections of 9 billion people by 2050. Right at the moment we have about 900 million of those people either malnourished or starving, 15% of the global population. That top figure shows the global caloric food demand. The bottom line is we'll need more calories in the next 50 years than were consumed in the last 500 years. That's a lot of calories, so there's a daunting challenge to grow more food. In the United States, we also have this mandate to produce liquid biofuels. So it's another stress on our landscape. Where are we going to get the feedstock to produce these impressive numbers of liquid biofuels? So I think there's a couple of terms that we're going to see a lot more of in the future. One is the term from the FAO, the sustainable intensification. The idea that we just can't pour on resources to increase productivity. We know that there are serious environmental consequences to that strategy, and that's just not going to work. So there's a sustainability component. We have to protect natural resources. It just can't be an all-out affair to grow more food. The second is the land equivalent ratio, and they're related. The land equivalent ratio is if you have a monoculture, your ratio is 1. But if you can mix things like trees with your crops or your animal production, you can increase the net productivity on your land and get that ratio above 1. So the more diverse, the more intercropping, the more sequence cropping that you can have, you can increase that ratio, you increase your productivity in a per land unit area. So those are both the terms, and I'm not going to steal anyone's thunder today, but those are both terms that agroforestry is really well poised to contribute to. And I think we're going to see a lot more discussion about those in the future. You know, there are people out there that say, Sauer, what is your problem? Life is good. Look at corn productivity. It's skyrocketing, right? Look at those yields. Well, there's 3 things I'd like to point out in this figure. One is yields were actually going down before World War II. Why was that? We were depleting our soils, right? We were farming out the nutrients in our soil organic matter. When we started to get commercial fertilizers, hybrid corn, post-World War II, yields start taking off, and boy, they really take off, and there's a nice trajectory there. One thing we know, we've all had enough biology to know, are yield curves all linear forever? I mean, there's no end, right? It can go to 1 million bushels per acre? No. So the question is, when and where will that curve plateau? We don't know. Lots of people talk about 300 bushel average yield corn. We'll get into that very soon about what I think about that. The other thing is, there's the 2012 yield for the drought year. Not really on the curve, is it? Another extreme event. Look at the consequences we have. Lots of people think that some of our commodity production is sort of bulletproof, resistant to climate variation. Well, that's not the case. we are vulnerable. Even in our intense, very high-tech production ag systems, we're still vulnerable. So here we go. Secretary Vilsack, just about a year ago, rolled out these regional climate hubs, and we have one of these in our laboratory in Ames. So there's the location of the 7. 3 are under Forest Service lead, 4 under Ag Research Service ARS lead. Note that their title is Risk Adaptation and Mitigation to Climate Change. One of the key features of the Climate Hub is there's a hint right down here. OCE. Anyone know what OCE is in the Department of Agriculture? The Office of the Chief Economist. It's no accident that the climate hubs are in the Office of the Chief Economist. This is big picture stuff. It's about risk. When they're talking about risk, they're talking about dollars. What's the cost? And if we're talking about adaptation or mitigation practices, a lot of the discussion is going to be about the cost. What's the investment? What's it going to take? What's the investment going to need to be? So here's the image, the sort of the plan for the climate hubs, the conceptual framework. I'd really like to point out these 2 arrows on the right because those are the keys. That is the information and the tools are flowing this direction from the researchers, the agencies, down to the stakeholders. But importantly, it's not just a top-down design. There are the questions and feedback that go from the stakeholders back through the system. If I'd have drawn this figure, all these arrows would have been double-headed because that's the idea of the Climate Hub, is the interaction. Our goal, our challenge, is to be the integrator, to take information from both directions, basically. Feeding back from the stakeholders to the researchers, taking information from researchers, packaging it hopefully in a clear, direct way that it's useful, more useful to those stakeholders. Here's one of the products from the Climate Hub. This is our first product, actually, Climate Risks in the Midwest. So it just gives an example of some of the types of material that how we're trying to frame things, basically what the risks are, what USDA is doing to try and address those risks. And this is just the first rollout of the type of material that we're planning to produce in the future. Well, what do we know about climate change? What's important? There's some good news, actually, right? Growing seasons are getting a little bit longer. That's good, right? Well, it's mostly good. There are still some issues about that because what's good for our crops, our forests, also good for pests and weeds, right? So they have a longer growing season. That's creating some interesting interactions and problems there. There's also issues about synchrony. If you need pollinators at a certain time for your plants, and the plants are now flowering at a different time, are your pollinators there when they need to be there? So there's good and bad to some of these changes that we're observing. Others, it's mostly bad. We have these extreme events. Hard to put sort of a positive spin on what the good is by having these extreme events and increased flooding. But I will say, and a lot of the talk is focused on management of water. I think in the future, the climate change challenges, the biggest challenge is going to be about managing water. And then we have the predictions. These are the ones that really drive people crazy. We run 10 different models, 5 different scenarios. What's really going to happen? How do you plan for a future that you don't know what it's going to be like? This is an interesting analysis here because one of the things it says is that precipitation in the southern plains and the mid-south is going to be a lot less in the summer. That doesn't sound good for agriculture and crop production. It's also going to have greater precipitation in the northern tiers of states in the winter and spring. That sounds like a later onset of growing season if you can't get in the field because the ground is too wet. So there are lots of scenarios out there. We're trying to sort through, and that's the real challenge I think that the Climate Hub has. Trying to distill down what's important. Out of all the noise, find the signal. That's one of the biggest challenges that we have. Right, I mentioned water. to have a 300 bushel yield, according to the data that we have, you need to have 30 inches of ET. It's really very close to 10 bushels per acre per inch of ET. Well, that's our water use efficiency. Water use efficiency is one of those linear trends. The more yield you have, the more water it takes to get there. Well, we don't have 30 inches of ET. Even in Iowa, we have 34 inches of precipitation. We'd have to basically store every drop of water in the soil profile, make it available to the plant when it needs it to get that 300 bushel of yield. Water management is going to be a big problem when we think about attaining some of the yields that people are projecting we can reach. I like this other study over here by Ermach, where he just measured plant available water in the root zone and predicted crop yield from it. That's a pretty simple model. How much water do I have? How much yield am I going to get? But it's really, in some ways, because our management is so good, our pest control is good, we provide proper nutrition, we know how to grow these crops. In some ways, it just comes down to, do we have the water to get there? Well, can we increase water? Well, there's a field not too far from here that's had the same management practices on it for, I don't know, it's over a century, I think now, the Sanborn field. One of the things we learn from experiments like that and why they're so important is that we've lost a lot of the organic matter in our soil. Roughly across the Midwest, about 50%. Well, with that loss of organic matter, we've done what this red arrow is doing. We've decreased our plant available water. The plant available water is this shaded area between field capacity and permanent wilting point. Above and below those lines, the water's just not available to plants. So we want to be over here where the curve is taller, the area is wider. But unfortunately, when we lose organic matter content, we go this direction. And so we actually lose plant available water. It's a really interesting paper. I encourage everyone to read Hudson, because it also gives a history about how we got it wrong in the beginning, this relationship between plant available water and soil organic matter. So he just took soil survey data and from a lot of different places and looked at soils with the same texture and different amounts of organic matter and came up with these relationships. Where we want to be is here. We want to take our soils that have maybe been eroded, tilled for 100 years or more perhaps, that have low organic matter, and increase it. In fact, if you increase your organic matter content from 1 to 4.5%, you double your plant available water. That's one way we can store more water in our soil to help build those greater crop yields. I really like soil organic matter. I have 3 degrees in soil science, work in micrometeorology and soil physics at a PhD, had a very underdeveloped appreciation for soil organic matter, and now I've seen the light. Soil organic matter is key. Not only from these biophysical functioning, but it has everything to do with crop nutrient cycling, so carbon cycling is also critical. You never have to worry about having too much soil organic matter. You never hear farmers complain, ooh, we've got too much soil organic matter. It's controlled by climate. High organic matter soils are healthier soils, more productive. And we really need to, and the NRCS has a big program in soil health, and a lot of that is about increasing soil organic matter. And that's a hard thing to do when we have the erosion rates that we still have in this country. We really need to turn that around to start building soils instead of allowing this sort of slow degradation of our agricultural soils. Bottom line is, we need to talk about building resilient agricultural systems. And there's lots of things, and I don't want to spend a lot of time on this, but I'm not saying soil organic matter is the only factor, but there are a lot of management practices out there that can contribute to resilient cropping systems. A lot of focus on water, efficient irrigation, controlled drainage, keeping more water in the soil profile, again, that plant available water. Reduced tillage, cover crops are becoming very popular in Iowa. Contours, crop rotations, some of these older practices that we were using them because of these soil and water conservation benefits, and we need to revisit some of them. They've kind of disappeared from modern agriculture in many ways. And then agroforestry. I think agroforestry is very well positioned, and again, there are other people on the program going to be talking about some of these details, but I think agroforestry is right there, really well poised to make some real contributions. Okay, sort of switching gears now, the World Agroforestry Center just in the last few weeks has rolled out this publication, Climatesmart Landscapes. So I think it's really, the timing is really great for this symposium today. But so let's talk a little bit about agroforestry and climate variability. First of all, we're going to look back because the relationship between forests and agriculture is kind of a checkered past, let's just say. When Europeans came to America, they basically came across forests. And so when they started farming, their use for forests was what? Cut the trees down, burn them up, use the nutrients in the ash to grow crops until the soil was exhausted, and then you move west. Curiously, when they got to the prairie soils, especially around that 98th meridian, which really seemed to be key, they said, there are no trees. And to farmers of that era, no trees meant nutrient-poor soils and not enough rain for agriculture. So they stopped. They said, well, we can't go into the prairies. Crops aren't going to grow there. It's sort of ironic because we know that the prairies were really nutrient-rich. You know, the rainfall was certainly a question. They were going into areas of lower rainfall. And so that's why you have people like Morton, the founder of the Arbor Foundation, saying things like, we need to plant trees. These are promoting tree planting for the economic feasibility. And then I like these, the psychological benefits, aesthetic qualities, and the morality of tree planting. He's trying to encourage farmers to plant trees in these prairie landscapes, and using some pretty persuasive arguments, if I must say. So what does the government do? We respond with the Timber Culture Act. People, you're familiar with the Homestead Act, where if you farmed a portion of 160 acres, you could then claim that if you farmed it for a period of years. There was an analogous program called the Tree Claim, where if you planted a certain number of acres of trees, you could claim that land. It wasn't a particularly popular program. I must say it was terribly abused, according to most of the historical records. But Senator Hitchcock had a really interesting comment about it, where he said, the object of this bill is to encourage the growth of timber, not merely for the benefit of the soil, not merely for the value of the timber itself, but for its influence upon the climate. Okay, so what are we talking about here? Well, you know, they said, well, you know, we had more rain where we had trees, so if we had more trees, we'll have more rain. That was a prevailing thought at the time. Well, this thought carried through. In fact, there's a really interesting report by this fellow, Rafaels Report, 1927, where he basically does a summary of the world's literature on the effect of forests and hydrology and precipitation, and he concludes forests increase both the abundance and frequency of precipitation by up to 25%. That's a photo of me, Kamenaya Steppe, a couple of miles from the Dukachayev statue, where they get less than 20 inches of rainfall a year, and I'm standing in basically a 100-year-old forest plantation in what we would consider a semi-arid steppe. The climate in that forest, by the way, was a lot different than when you stepped outside of it in the forest steppe. That's what people observed. That's what Zahn is talking about, is the effect on these forest blocks, on local climate. Okay, so I think, you know, when I was preparing this talk, I really think agroforestry probably has one of the best arguments for climate change mitigation and adaptation techniques by virtue of a program that occurred during the Dust Bowl. In the 1930s, poor land management coupled with several years of severe drought, throw in the economic depression, we had a disaster in the Great Plains. President Roosevelt was absolutely committed to try and keep people on the plains. That was one of his top priorities. He didn't want them leaving. He was afraid they would abandon this land, never known would ever come back. The government's response this time was the Prairie States Forestry Project. In 1935, they rolled out this document, a 200-page document called Possibilities of Shelter Belt Planting in the Plains Region. So here was their zone of planting, 100 miles wide, 1,150 miles long. They said, we're going to target this area and we're going to plant windbreaks throughout this region. And that's going to help control the wind erosion, improve the local microclimate, and very controversially, bring rain to the Great Plains. It's a 200-page document. If you read it, it's the best feasibility analysis I've ever read. They were very, very, very thorough. These people were passionate about this idea. And Zahn was one of the authors of these chapters, and they cover the whole gamut here. For its day, very comprehensive, including the social science aspects of planting trees in a plains region. They covered groundwater hydrology, precipitation, growing trees from local seed stock. They covered everything, very comprehensive. Went to Secretary of Agriculture Wallace, again FDR, President Roosevelt in the White House. He called them his trees. This was a program that was very important to him personally. So it went forward. From 1935 to the beginning of World War II, they planted 217 million trees in the shelter belt zone. There's the zone, and actually the dark areas where they actually planted the trees. Interesting to think about what would happen if the war hadn't come, how this program would have played out. If it would have continued, we don't know. The war came, the program ended. I would argue that this program is the Apollo moonshot of agroforestry. There was a crisis, there was a challenge. The response was an agroforestry application to a climate threat. What other management practice can you think of has an analogy like this to deal with global climate change, an adaptation and mitigation technique? We got the Prairie State Forestry Planting Project. It's also called the Shelter Belt Project. This is probably the high point, though, because the project just ends after World War II. They do a follow-up study in 1958 to actually see how the trees were doing. So it's all very scientific, science-based approach to this project. Very well done. Well, what were they? They were basically using anecdotal data up to that point. It was sort of interesting. They have this nice feasibility study, but none of the data, very little of the data actually came from the Great Plains of the US. They reviewed literature from other places. And we now know that if you think, here's your windbreak, this is distance and heights, H is height, downwind. We now know that we can summarize lots of data, subsequent data, that it has a positive effect on crop yield, soil moisture, etc. Down here, it reduces evaporation, reduces wind speed. So there's this protective effect of the windbreaks that enhances crop growth. And there's been a lot of research done, subsequent research done to verify these. And we have tables now of data where it showed lots of years of information, different crops, different locations, what the benefits of this protective zone from the windbreaks is. But how did they get this idea, and who pushed it? I mentioned the report by Zahn earlier, and by the way, here's an example of the shelter zone. Originally, the zone went to the Gulf of Mexico. They've changed things a lot over the development of the program. They also, at one time, said they were going to plant north-south windbreaks every mile from the Gulf of Mexico to California, in the middle of every section throughout the whole zone. So they scaled things back a little bit, a sort of reality check at some point about what they could actually achieve. This character, Rafael Zahn, was a key player in this, a key proponent. The interesting thing about Zahn, that he was Russian. He was actually sort of in trouble with the law in Russia, so had kind of a hasty exit, went to Europe, and was in the first graduating class of foresters from Cornell. He knew of Dukachayev from his work at Kamenaya Steppe in Russia. And I think it's really clear, actually, that Zahn got the idea for the Prairie States Forestry Project from the work that had been done in Russia. So here's Dukachayev again. Dukachayev, very interesting character. the Tsar and ministers of Russia, there was another drought and a famine in the steppes. Famine is bad. That leads to political unrest. The Tsar was very interested in ending famines. And so what do? They say, well, who's our all-star? Who's our best guy that we can send down there? They chose Dokuchayev. He led an expedition to Kamenaya Steppe. His job, and everyone would love to have a task like this. Your objective is to end the droughts. Okay? Pretty open-ended, pretty daunting. But Dokuchayev takes the challenge, goes to Kamenaya Steppe, leads an expedition there, and he comes up with this plan in 1892. It's all about water. How we can conserve water, how we can reduce evaporation, save as much water as we can for growing crops, for growing our food. So that's the Dokuchayev plan. So if he's the father of soil science, what I'd like to introduce today is the concept that perhaps he's the great uncle of temperate agroforestry, because the Dokuchayev plan included the idea of planting these windbreaks in a semi-arid area. The idea in the data that they collected during his period was that it increased crop yields 15%. Conserving the moisture, reducing moisture stress. There was the physical protection from these winds they called Sokovis. There is arid regions to the southeast of Kamenaya, and they'd get these hot, dry winds blowing off these arid regions, and it would desiccate their crops in a period of 2 or 3 days, end of growing season. It was all over. And so he believed that these windbreaks could protect the crops from these Sokovis. Not only windbreaks, but he had riparian plantings to stabilize the banks of rivers. They also planted trees along ponds and gullies to shade the water for slope stabilization. And in the end, they planted 320,000 acres of windbreaks by 1900. This program, this idea of planting tree windbreaks in the semi-arid steppe continued. It carried on through the various transformations of the Russian and Soviet governments, but it became an established practice in the region. And, continuing on, focusing on the crop yield. And here's some data, all of this from Kamenaya Steppe, where they're looking at yields, again, these different crops increasing from 6 to 300%. We're talking about food security. These are important numbers that, we're looking for ways to enhance productivity, right? So here we go. These were working in this semi-arid area. Not to be outdone, Comrade Stalin had an even bigger plan. And so, this was all about changing the climate. They believed that the steppes had become drier. And when they were more moist, they had more trees. So again, it was the same argument. Well, if we have more trees, we're going to increase the rainfall, and the steppe will become better, more productive for agriculture. Stalin took this in a big way. After World War II, based on some of the ideas of Dokuchayev, they were going to create these arborways, and I'll show a map in a moment, but the goal here was to plant 14 million acres. Now we're talking 300,000 in these other programs. Now we're talking 14 million acres. And it included some agronomic enhancements as well, including big sort of TVA scale irrigation projects. And here's the poster that I like. Comrade Stalin in his army uniform saying, we're going to defeat the drought. It was a sort of a military image, the campaign, by planting all of these shelter belts and windbreaks in the southern steppe to change the climate of the steppe, to end the drought. And today, everywhere I drove in the region, when we're visiting the area, there are trees everywhere. They're still planting them. It's still it's sort of ingrained now into the local culture that this is what we do. We plant windbreaks and shelter belts. No, in the time I have left, I want to talk a little bit about some personal research. I mentioned my colleague, Yuri Chendev from Belgorod State University. We were very fortunate to have a grant together, and this focused on agroforestry, but from sort of a modern perspective. Now we're talking about bioenergy and sustainable intensification. So we had this opportunity to evaluate a sustainability aspect, that being soil organic carbon We're talking carbon sequestration and soil health, plus the bioenergy potential of these trees. And then the last component was scaling this up to the regional scale, at least at the United States component of this project. So we actually went to Kamenaya Steppe. We sampled a windbreak there. We sampled 2 others in Russia. And in 2012, we also sampled 3 in the United States. 2013, 3 more over here. The Norfolk, Nebraska site was a prairie state forestry planting from 1942. These sites were all planted during the Stalin Plan era. And they have a gradient of mean annual temperature and precipitation. And this HTC is the hydrothermal coefficient, which is a climate index. So we're looking over a range of temperature, precipitation, to try and see the interaction between climate change and the observed changes in soil organic carbon and biomass. Just real briefly, some data. This is the soil organic carbon content beneath the trees. The green shaded areas are where the trees are, and then there's croplands or grass on either side. All the sites we found that we had increased organic carbon beneath the trees. And these are on different soils, different tree species, different age of plantings. We saw the same trend. But perhaps really the most interesting aspect of this is how the sites from the 2 countries fit together. Here's that hydrothermal coefficient down here. This is warm and dry. And this axis is the difference in the thickness of the organic rich surface layers between under the trees and in native grasslands at the same locations. So if this is a positive number above 0, that means that we had a thicker organic horizon beneath the trees than we had under the native vegetation. So we had changed the microclimate. We think it became more cool and moist beneath the trees, and that favored the accumulation of soil organic carbon. Below this line, it's not happening. So the hotter and drier the sites we had, in the US and in Russia, we're not seeing that effect. So we're not sequestering more carbon beneath the trees at those locations compared to the native land use. So a very interesting sort of summary slide of that whole project and how it worked out in terms of the carbon. Well, I mentioned we wanted to scale this up, and this is, sort of our, I won't say our possibilities of shelter belt planting because it pales by comparison with that 1935 document. But it was a GIS analysis where we looked at a productivity index, soil characteristics, the crop data layers, and we came down with what our definition of a marginal soils and said, look, we don't want to take prime farmland out of production, but what's the possibility? Let's go in there and take marginal lands. If we planted tree windbreaks on those marginal lands, we'd get the benefit of protecting the crops. We have potential bioenergy production, and we have potential increasing in soil organic carbon. It's a win-win-win-win situation. So that was the sort of summary of this project was the what if. Well, the what if is that this marginal soils that we delineated turned out to be about 1.6 million hectares, and that's 3.15% of the actual cropland in these 3 states. And we estimated that we could sequester 13,000 some metric tons of carbon per year if we were to plant 1 50-meter wide windbreak in every quarter section of this marginal land. Well, I'd like to summarize now my comments. I hope you enjoyed the story about Russia. It was fun researching that and the connection between Dukachayev, the father of soil science, and now the great uncle of agroforestry. But we don't want to candy coat it either. There's some real challenges out there. We don't know what the future is going to bring. That's part of the reason for our inability, it seems, to address the climate change issues. The Dust Bowl was a sort of an easy one. We knew there was a serious problem. We knew it was going on. We applied this solution to it. It worked. But climate change is a bit more larger, complex issue. It's going to be more difficult. But we know that climate variability is out there. It's going to be a challenge. It seems to be increasing. There are real consequences to ag production. We're going to have to adapt. In fact, you know, in some ways, I think we don't even need to talk about adaptation. Adaptation is going to happen. I mean, growers are not going to put up with crop failure before they're going to start changing. I mean, so mitigation techniques, yes. Adaptation is going to happen. We're going to intensify our land use. We need more. We need more of everything for a growing population. So the stress on our natural resources is going to increase. I really think agroforestry is well poised. I think, and it's not just my personal opinion because I'm a fan of agroforestry. I like agroforestry practices. I mean, just looking at the facts and the data, here's a management practice that has been used in the past on a large scale. We know it works. We know what the benefits are. That doesn't mean we don't need to do any research either, because we have modern varieties, modern hybrids, changing climate. We do need to know what's going to work in future climates as well. And lastly, I really hope that the regional climate hubs, and our role as sort of the integrator, I sometimes say the wise men, but maybe that's not a real good analogy. The image of the climate hub are the integrators of knowledge, the filterers of knowledge, and that's the real challenge. And I hope that we have a strong role to play, and agroforestry is going to be one of those areas that those hubs are going to contribute to. So thank you for your attention.
Thank you, Tom. We have a few minutes for questions or comments from audience members, and there'll be a microphone that's coming around. Please use it so that individuals who are on the stream can hear.
Hi, great talk, great slides. Have any of the old shelter belts in Russia or the U.S. been converted for use as bioenergy feedstock, specifically coppicing the woody stems and letting the trees come back from stump sprouting? And if so, what have the impacts been on soil carbon?
Yeah, that's a good question. To my knowledge, this hasn't happened. And our research project was basically exploring the idea, and you know what it didn't include in the introduction there was the justification for the work is the renovation of these shelter belts. Essentially what happens, especially in the U.S., when due to things like spray drift and the species that were selected in the 1930s, the shelter belts are dying. They've reached their maturity. The one in Norfolk actually reseeded with species that weren't planted there. So it naturally regenerated itself, but not many of them have. And so they're not very effective anymore. People are just taking them out. Commodity prices are high, so they just convert that land back into crop production. What we were trying to sell in that grant proposal was the idea, well, what if, we remove that material that's there, we can use that right now, and then if we change to something that maybe has a shorter rotation that would be conducive to the coppicing for specific bioenergy uses. So a regeneration, if you will, a natural regeneration, to something that's more modern production practice. We'll see. We have a SARE project, Sustainable Ag Research and Extension Project, and it's looking at the economics of this. How many trees would you have to have? It's just like every other bioenergy study. Where are you going to get the feedstock? How much do you need for a pilot plant or any production? Where are you going to get it? What are the economics of transferring it? And that's all in that SARE grant that's ongoing. Thank you.
Being a forester, I got a question for you. Back in the late 1800s to 1900, when they had all these windbreaks and all being planted, where in the world did they get the tree seedlings to plant them? Because that was basically before the era of tree nurseries.
Yeah, and another good question. I grew up, and I don't know for certain, but about a quarter of a mile from our house, there was a grove of cottonwoods out in the middle of the field. I'm guessing that it was a tree claim. There was no other reason for, in the middle of a Minnesota farm field, to have a 5-acre patch of cottonwood trees. Of course, they cut them down eventually. But from what I understand, they would go to river bottoms and they would find tree seedlings. And that's where they would get, and that's why many of these plantings were things like cottonwood. They were native species to their area, and so they would go and find seedlings, and that's what they would use for some of these plantings. I've never seen that question really directly addressed in like any of the historical literature, but I've just seen it alluded to a couple of times is that, well, they use native species. Well, the only place they were going to get them, the most likely place that they were going to get them was from these protected areas and river bottoms. Another question?
Hey, Tom, great talk. I really enjoyed it. I think you convinced everybody sitting here and listening to you that planting trees is a good thing.
Yeah.
But if you look at what has been happening over the last 3-4 years, we've seen a lot of these windbreaks and trees on farms coming down, taken out to have more acreage for corn or soybean or other crops. So it's true, the beneficial effects of tree planting are there, but how would you convince landowners it is a good thing? Well, obviously, decades ago they were convinced, but now how do we convince the farmers of today?
It's a tough sell. And the reason it's a tough sell is because, the American business model is next quarter. The American agricultural model is this growing season. When you're planting trees, you're talking about next decade or the next several decades. So there's one of the real problems is the time. So how do you get people over that hurdle of investing today for benefit somewhat later, and perhaps not even a benefit to me? I'm of an age where I may not see the benefit to me personally. I don't know the answer to that question. I think it's not necessarily a science issue. If it is, it's a social science issue. It's about people's perception about the commitment they want to make to the future. And that's not sort of a pervasive attitude in American society, I must say. That's not often how we think. And so it takes a change in thinking. And, I know I shouldn't say this, it's probably being recorded, but more data isn't always the answer when you're trying to convince people on questions like this. Because I don't think data is the convincing thing to them. It's values. What do they value?
As you described the shelter belts, they struck me as relatively static. They're there to protect an annual grain crop, to protect perhaps a perennial grassland. Was there ever, or is there a vision of these shelter belts as in and of themselves food producers, using nut trees, fruit trees, so these areas that are, as you described, potentially taken out of some marginal areas, instead of being a static protector for an already stressed grain crop, being a food producer on their own, which produces jobs and food while providing this? Has that ever been or will it be discussed as a major use of these practices?
It's not really had a lot of traction, but that's where we need to go. Those need to be multifunctional, and there's no reason that we cannot incorporate food-producing species into these. There's no reason we can't. It's a question of how we do it, what it will take, what sort of management it will take to do that. That's the land equivalent ratio in a nutshell right there. Is if we're planting trees, can we get increased productivity of food plus all of these other ecosystem services, the sheltering effects, et cetera. That's the golden nugget, if you will, right there.
So, in terms of then convincing the landowner who's bottom line oriented, and the culture is I need to make money this year, then an approach is something that we call market-based conservation, so that when folks are putting in something that used to be straight-up conservation, the dialogue is you will be starting to earn income from this over and above what you already have. Mm-hmm. So we call it market-based conservation because everybody's thinking market as a way in.
Yep, I think those sort of analyses were really helpful because that'll help convince people that here's your return, here's what's coming, putting value to it.
Shibu, I think we probably need to move on, so would you join me in thanking Tom Sauer for that interesting presentation?
Thank you.